We use many of the same tools when solving a problem or a one-off deviation that we use when improving the process, making up new standards. Now, the tools may look the same, but the way you use them is really different. And if you mix it up between use cases, you may actually be hurting your continuous improvement process. So stay tuned. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And what we'll often see is that our Lean and Six Sigma is a lot about which tools to use. So you've got your A3s and your fishbones. We've got a fishbone over here that you need to use in specific situations as asked by management. There is a real difference in how we use specific tools, because that's what they are. They're just tools. They are usually ways to help us structure our thoughts. But when we are talking about problems, one-off things, or we are really redesigning our process to become more efficient, or we have a whole slew of variation, there is a difference in how to use the tools, because we have to approach the problem in a different way, think in a different way. So we'll go over what I mean with problem versus improvement, and then into how you need to think what the outcome should be, and based on that, how to use the tools. Maybe you've seen my video about the infinite loop. You control your performance and you improve your process. And as soon as you improve your process, you got a new standard which you again control. And from time to time, you do an entire visioning cycle to see, do we benchmark, how do we improve? It's a nice framework to use when discussing how you are managing your factory. Now, on here is also a point which is solving your problem. So this is root cause problem solving. Root cause analysis, root cause problem solving. To get back in control when you see a deviation. And what do we mean? We have a standard to which we operate, and this can be either a performance standard, but can also be a work standard that is at some point not being followed. Then in your control loop, you notice this and you start your improvement to get back to the standard. This is solving a problem because you know what the standard is. Now, in the process, you may slightly change some of the work standards, but usually you mainly get back to really the way you were used to work before. Then also what you can do is you can say, no, I would like to increase my performance, do it better than we've ever done before. That basically means that you are improving the level of your standard and going to a new standard. And that is improving the process. Now, a question I often get is, well, but isn't this basically the same? It's just here we made the standard once, so we know we can get back. Here we don't really know yet if we can get there. A bit more risk, but for the rest the same process. Not really. But many managers will think of it, see it as more or less the same way. And here is going to be one of the nice things if you are into using control charts, statistical process control, or just regular control charts. What you can see, a couple of scenarios, is we've got basically a stable process, and then suddenly it is stable at a totally different level. So here, this drop from the baseline to a new baseline, you have probably got one root cause that is responsible for this, and also this is a deviation from what you expected. So you really put control stuff on this. More or less on the other end of the spectrum, you've got a process that is already not very good to start with. So you've got many points that are outside your control limits. The first time this happens, some people might say that there has been a shift in your process. But here is why it's important to look back at a little piece of history. If you have them on all sides, so basically this process is just not capable. This process will not stick within your control limits, or more likely in this case the specification limits, because probably you have not had a Six Sigma engineer really take a good look at these limits and at these control charts yet. But this is not a single root cause. And what you can also see from time to time is that you have a process that is basically in control, and then at some point it just starts to deviate. Now, the latter part of this graph might look like that one, but basically what we see is that there was a split from a roughly centered and very nicely capable process towards a mess, basically. This also usually has a single root cause that caused lots of variation. So something probably in your machinery, but maybe also just people, material change caused a lot of variation. So a shift, suddenly a lot of variation. This is a problem with probably one root cause. When you've had some trouble from the start and it's just in your process, you need to really do some capability improvement of your whole process. And this type of work, first of all, that takes a couple of months, easily a 3-month project. This will take a couple of days, maybe 2 weeks, but you're pushing it. But there's also a really different way to then use the tools. So when we're talking root cause problem solving, you should apply it to those two. When we're talking improvement and process optimization, we're going to talk about that type of tools that we use. Now you see, a fishbone is a really good tool for both of them to start with. But there is a very different way of approaching it. If you know that you're basically looking for 1, maybe 2 root causes, so you have some breakpoints, you have a couple of things that just align so that now you have a problem that you did not have before. You are looking for those causes that changed. And basically what you're doing is brainstorming all the possible factors that will influence this change, and then you start eliminating them. You say, no, we checked that, it's not it. And at some point you say, well, these we don't really know, they could be it. What's the most likely? Let's go into a 5 why to find a root cause. And maybe you see that you need to do a second 5 why on a second of these possible causes. But the basic way you now use your tools is you brainstorm possible causes and then really cut away possible causes by eliminating them. You validate them out of your scope and you only dig deep on a few of them. Now, when we are talking about process improvement, we also want to do a good brainstorm of which parameters introduce variability, spread, unreliability into our process. But this time we are trying to find all those parameters and settings that will make our process stable or variable. And we're going to check which of the things we found will probably have a serious impact on the variability and are controllable. So those few that we take away are those that we cannot control anyway, so we will have to use other parameters to control this one. But most of them will be selected and we say, look, these are our controllable parameters. Let's find the most optimal settings with this combination. And that's when you start making this list of parameters and settings for your process. So these are machine settings, but they are also material things. They are also how to do the maintenance. They're also how to load. The 4 M's are completely in scope, and you just list those parameters. And there will be some that are on a scale where your job basically afterwards is to say that was the ideal level. And for parameter 2, it's over there. And this one also over there. This one has to be very minimal. And there will be a number of parameters that you just have to check. Do we switch on a machine or not? Do we do a certain action or not? And we say, well, here we have to do it. This one, yeah, better if we do it. Last one, no, better result if we do not do that part of the process or do not switch on this setting. You are looking for the optimal settings and parameters to stabilize the process. You're not looking for a single root cause. Also, you do not need a 5 why analysis on why these settings were not optimal. You already know that. You did not check it before. Now you just have to make sure that they become very sustainable, stable settings to reduce the variability. Both of these are very important tools in your Lean Six Sigma toolbox, but know how to use them. And that, of course, is the job of you as a continuous improvement specialist. The tools look the same, you make the difference. Now, if you like this explanation, don't forget to hit that like button, subscribe to my channel if you haven't done so already, and drop me a comment. Is this different use of the same tool common knowledge, or did something in my video open your eyes? Did you get any nice new insight? I'd love to know. Drop me a comment below. And for now, I wish you the best of luck in your continuous improvement and problem solving journey. And as always, enjoy that journey.